Hello. Okay. So today we are going to begin with the data link controls. And the very first thing in data link control is a protocol. This protocol is basically a data link layer protocol. This protocol is basically a data link layer protocol. It's called as HDLC. It stands for High Level Data Link Control. Basically, it is a communication protocol of data link layer, of course, for transferring data between network points or between the nodes. We all know this, that we have studied that data link protocol, the data is divided into frames basically, where all the encryption information by the data link layer is basically stored along with the data to be transferred. So we transmit a frame from a destination, from source to destination, and we verify whether there has been a successful arrival or not, depend as we have seen in OSI reference model. This HDLC protocol is basically a bit oriented protocol, which allows us both point to point and multi point communication. Now, every protocol has some format, the frame format basically. So here we have the HDLC frame format. This is how your frame basically looks. This is how your frame of HDLC, or the data link control protocol HDLC, looks like. We have a flag, which is 1 byte address, 1 byte control, payload, FCS, and flag. So let's understand what this points are basically. So as we know, it's a bit oriented protocol. Each frame consists of six fields. Each frame consists of six fields. Flag is basically a 8-bit sequence that marks the beginning and the end of the frame. So a flag is basically constant, and the 8-bit frame at the start and the end is going to be this. So the 8-bit letter in the binary form is going to be something called as this. So whenever this is encountered by the destination, it understands a HDLC package has been coming, and this is the start of the HDLC frame. So we are basically transferring data in form of frames from one PC to another PC. And to understand the start and the end of the frame, whenever it encounters this specific binary number, it understands either it's the start or the end of the frame. So that is how, this is why we require a flag. Now the next is the address. Basically, it contains the address of the receiver. So whatever the destination address is, that will be mentioned right here. Next are the control bits. It is either 1 or 2 bits. It contains basically flow and error control information. Next, we have the payload, which carries the actual data from the network layer, the data that comes in the form of packets. So network layer builds up packets. These packets are put into frames right here on the data link layer. And so this basically, the data, actual data, is basically put into the payload. uh, its length might vary depending on what the size of the packet is, that is decided by the network layer, and what data a sender wants to send basically. Next is FCS, again 2 or 4 bytes. This is for error detection, and we use cyclic redundancy code for the same. We use cyclic redundancy code for the same, which is an error detection mechanism available in computer network, and this is something that we'll be using. So this is basically the frames, how they look. Now basically we have three kind of HDLC frame, which your one is I frame, which stands for information frames. One is S frames, which stands for supervisory frames, and one is U frame, which stands for unnumbered frames. Now, what are they basically? The difference between the frames is right here. You all will notice that the first one is the actual HDLC frame that we saw. This is mainly the information frame, and it is responsible to carry user data. Okay, it's responsible to carry the user data. Supervisory frame does not contain the information field. So basically, it's not responsible to carry the user data. It's not going to be used to carry the actual data. it is only used for flow control and error control. It is only used for flow control and error control. Then there is unnumbered frames, which is just for miscellaneous functions like link management. It may contain information field if required, but normally it's mainly used for link management. What is link management? Establishing a connection between the sender and the receiver. That is something that is a task that is performed by U-frame. By sending U-frames from sender to receiver and the receiver to sender, we can establish link management, or establish the connection. We can check if the connection is proper or not. So here it is. This is the main frame that is normally used. S frame is basically supervisory information. That is, if you want to send something specific regarding error control and error detection, and there is no data to send, then we can use the supervisory frame. You can see the data field right here is not available. Here the management information goes. Basically this has data field but normally contains management information with regard to connection establishment, and the rest of the fields are the same in everything. So this is basically your HDLC.